Hi, this is lesson 8.2, and we are going to be talking about some special right triangles. Now, typically with right triangles, if we know two sides, we can find the third side by using the Pythagorean theorem. But when we're working with a 45, 45, 90, and also with a 30, 60, 90, we only need to know one side if we know what the extended ratios are. So first of all, with a 45, 45, 90, we have two congruent angles, which means it's an isosceles triangle. So two of the sides are the same. So the ratio with every 45, 45, 90 triangle is 1 to 1 to the square root of 2. The hypotenuse is always the longest, so it's the square root of 2 times longer. So for example, if this is 45, this is 90, this is 45. So in your standard 45, 45, 90, if the two legs are 1 and 1, the hypotenuse is root 2. Here's another one sitting at the other direction. So the legs are the same, the hypotenuse is root 2. Here, this is 45, 45, 90. The legs are both 1, the hypotenuse is root 2. So using that triangle, we can find missing lengths of any 45, 45, 90 of various leg lengths and hypotenuse lengths. Here's what you do. It says find the length of the hypotenuse. We're actually going to find both sides. I'm going to call this side x, this side y. So this is a 45, 45, 90. We're going to make a little model one underneath. And the sides, the legs are 1 and 1. The hypotenuse is root 2. So every 45, 45, 90 has that ratio, extended ratio for sides. So then we can use what we learned about proportions to find the missing length. So x is to 1. And then we choose the two sides that we know as 8 is to 1. So we're doing left side to left side, right side to right side. And you can cross multiply. X equals 8 times 1, so x equals 8. Notice, it is a 45, 45, 90, which means it's isosceles. So if this is 8, this will also be 8. So you could avoid doing the proportions if you remember that. Then let's find y. Y is equal, or y is to the square root of 2. So y is to the square root of 2 as 8 is to 1. So bottom to bottom, right side to right side. Cross multiply. Y is equal to 8 times the square root of 2. And that's as far as we can go unless you put it in a calculator and rounded your answer. So that's how we can find the sides. Now let's do another one. These sides are congruent, which means it's a 45, 45, 90. So we have to find the hypotenuse, so we'll just call that y. So again, I'm going to make just a general 45, 45, 90. So the legs are 1, 1, root 2. Just always go back to that basic triangle. So we are looking for y. Well, y corresponds to root 2 in the other one. And then we can choose either set of sides here, legs. So 3 root 2 corresponds to 1. So we have hypotenuse to hypotenuse, left leg to left leg. Cross multiply. Y will equal 3 root 2 times root 2. And we have to remember our rules about multiplying radicals. You can multiply the radicals together. So you have 3 times the square root of 4, because root 2 times root 2 is root 4, which is 3 times, well, the square root of 4 is 2. So your final answer is 6. So y is equal to 6. And let's just do one more. You have 5 root 2 for the hypotenuse. Again, these legs are the same, which means these angles are congruent. So we'll draw another 45, 45, 90 underneath. Right angles at the bottom. And the legs are 1, 1, hypotenuse is root 2. So we want to find x. X corresponds to 1. So we can say x is to 1 And then the hypotenuse here is 5 root 2. The hypotenuse here is root 2. So we're doing left side to left side, top to top. So we cross multiply. So you have the square root of 2 times x equals 5 times the square root of 2. Now to get x by itself, the opposite of multiplying is divide. So we have to divide both sides by root 2. So x equals, well, over here we have a root 2 over root 2, so those would cancel, so you just have 5. With a problem like this, you could have just canceled the root 2's right away too, because root 2 over root 2 is just 1, so then x would equal 5. So that would have saved you some steps. Okay, so those are your 45, 45, 90s. Let's just quick do one like this here with a square. So this angle's 90, and one of the properties of squares is that the diagonals bisect the angles. I should say it's a property of a rhombus, but a square is a rhombus. So these angles, the sum is 90, which means half of it's 45. So this is a 45, 45, 90. So to find D, we'll just take the top triangle here, the one on the left. This is 45. This is 45. And again, your basic 45, 45, 90 is 1, 1, root 2. So we're looking for D. Well, that D is the hypotenuse, so it corresponds to this. So we would say D is to the square root of 2 as 8 is to 1. So if we cross multiply, D times 1 is D, and that equals to A, 8 times the square root of 2. So there is your answer. All right, the next type of special triangle we're going to talk about is a 30, 60, 90 triangle. So the extended ratio in a 30, 60, 90 is 1 to 2 to the square root of 3. Now the square root of 3, let me punch that into a calculator. The square root of 3 is approximately 1.7. So the longest side here is 2. So in a 30, 60, 90, the shortest side is 1, and that's going to be across from the smallest angle. So if this is 30, across from the 30 is a 1. This angle's 90. That's the largest angle, so the longest side will be across from that. So that's going to be 2. And then 60 is the middle length, which is about 1.7, or root 3. So every 30, 60, 90 will have this pattern. Your short side is 1. Your hypotenuse is double that, or 2. And then the long leg is the square root of 3 times longer than the short leg. So we're going to practice just labeling a few of these. If this is 30 and that's 90, this would be 60. So the smallest angle is 30. Across from that is 1. The hypotenuse is the longest, so that's 2. And then the middle length is root 3. That's across from the middle-sized angle. So here we have a 60. Here we have a 30. There we have 90. So across from the 30 is 1. Hypotenuse is 2. Across from the 60 is root 3. To practice it again, this is the 30-degree angle down here. So across from the 30 is 1. Hypotenuse is 2. This is the 60. Across from that is root 3. We have to memorize that. So this is a 30. Across from that is 1. Hypotenuse is 2. The middle, or the longer leg, is root 3. Okay, so let's look at how we can solve some of these. You have a 30, 60, 90. We have to find 2 of the sides. We only have 1, so we can't use the Pythagorean theorem. We don't have enough information to do that. So this is 30, and this is 60. So first of all, this is our generic 30, 60, 90. Across from the 30 is 1 all the time. Across from the hypotenuse is 2, and across from the 60 is root 3. Okay, so we're going to find x first. We'll start with one of them. Well, x corresponds to the 1, the short side to the short side. And then the other sides that we have are the 9 and the root 3. So we cross multiply, so you have 9 times 1 equals the square root of 3 times x. To get x by itself, you divide by root 3. So that's your answer. X is 9 over the square root of 3. Next year, we're going to learn about how we can rewrite this so that we don't have a radical. But right now, we're not going to do that, okay? So it's 9 over divided by the square root of 3. Then to find the y, y corresponds to 2, the hypotenuse to the hypotenuse. And again, we'll do the bottom to the bottom, which is 9 over the square root of 3. So that gives us the square root of 3 times y equals 9 times 2, which is 18. So we'll divide by root 3, and we end up with y equals 18 over the square root of 3. Okay, let's just do one more here before we go. So again, I'm going to draw a triangle similar to what I see above. The angles in the corresponding spots across from the 30 is 1, the hypotenuse is 2, and the long leg is root 3. So if we have to find the value of x, okay, that's the bottom side there, we'll say x is to the square root of 3, and then we'll do the left side to the left side. So as the square root of 3 is to 1. And we cross multiply, so x equals the square root of 3 times the square root of 3, which is the square root of 9, and that equals 3. Okay, that's it for this lesson. Thanks for watching.